Hi there! Welcome back to our academy. In this lesson, we will walk you through the basics of blockchain. Let's start with the definition. What is a blockchain? In short, it's a database. But it would be more illustrative to explore it through an example. Imagine you, Dan, Steve and Paolo run a business. Dan is keeping all the books. When you spend money or make a sale, he updates it in the spreadsheet. There is a problem though. Dan controls everything. He can tamper with the data, add a personal bonus here and there, or do whatever well-meaning but misguided do-gooders do with no oversight. Now imagine the same scenario, but instead of a spreadsheet, you have a digital ledger that is accessible to all four of you. That's blockchain. Every time you make a sale, it's not just Dan typing it. It's four of you agreeing on the sale and adding it to the record together. That's how blockchain works. It is run and maintained by the network of computers called nodes. Every transaction is collectively agreed and added into the database. And since everyone has a copy, the blockchain acts as a single source of truth. No need for the middleman to tell you what's right and wrong. Think of it as the direct democracy of a databases. A blockchain is add-only as well. You can add new entries, but cannot remove or change what is already there. The thing is, transactions on the blockchain are handled together with blocks. And every block is cryptographically linked to the previous one. In simple words, it has sort of a digital stamp that points back to everything that happened on the chain before it. This stamp is called a hash. If you tamper with the record, this hash would change. And so would the hashes of all the records that came after it. You cannot change the data of the blockchain without anyone noticing. That's why it's considered transparent, secure, and immutable. So let's recap. A blockchain is a type of a database, but unlike your standard database, it has a particular way of storing data. Every new entry is cryptographically linked to the previous one, which makes it hard to tamper with the data. A blockchain doesn't belong to one entity. Instead, it is shared among all network participants. Everyone has a copy and helps maintain the database. That's essentially it when it comes to defining blockchain. Now, you may be wondering, why did we come up with the decentralized database in the first place? And we get you covered. The first seeds of what would eventually develop into blockchain were sown in 1990s. That's where Stuart Haber and W. Scott Stornetta created a system to stop tampering with digital files. They suggested making files with a timestamp, which is kind of an early version of what now we call a hash. At around the same time, tech folks began playing with an idea of digital currency. Several ideas were developed, but there was a challenge to overcome: double spending. Now you cannot spend a $10 paper bill twice, but you can copy a digital coin and spend it elsewhere. Or rather could, thanks to Hal Finney, who solved the double spending problem. He suggested recording the ownership of tokens on a trusted server, the mechanism that's called the reusable proof of work. Then comes 2008. Satoshi Nakamoto introduces Bitcoin. You probably heard about that one. Frustrated with how governments navigated the 2008 financial crisis, Nakamoto introduced a whole new financial system. It is decentralized, meaning no banks are involved and relies on a peer-to-peer network. This system borrowed the ideas of Haber, Stornetta, and Finney using timestamps and proof of work. Things got even more serious a few years later. Vitalik Buterin, co-founder of Bitcoin magazine, came up with Ethereum. It was a blockchain too, but instead of focusing on digital money, it has all sorts of potential use cases. Indeed, Buterin envisioned as a platform for running decentralized applications, or dApps. These apps could secure digital files and automate agreements between people. Ethereum also had its own coding language that allowed programmers to build new applications on the same blockchain. That's a story of how blockchains came to be. Today, it is getting even more secure and sophisticated, with better protocols, wallets, and ways for computers to agree on things. And guess what? It's not just about cryptocurrencies anymore. Blockchain is finding its way to everything from healthcare to gaming to managing identities, voting systems, and supply chains. But before we jump into all of the things blockchains can do, let's rewind to 2008. Remember how we said that Bitcoin was a product of frustration with traditional finance? Let's see how it differs from the system it broke away from. The root problem with conventional currency is all the trust it requires to make it work. The central bank must be trusted not to debase the currency, but the history of fiat currencies is full of breaches of that trust, said Satoshi Nakamoto in a 2009 blog post. Indeed, fiat money depends heavily on governments. The governments create money and says it's a legal tender. Its value hinges entirely on trust. Trust that the government will control the money supply. Essentially, fiat money has value because we all agree it does. The value of fiat money also depends on supply and demand. If there is too much, it can become less valuable, which leads to inflation. Here comes the catch. Governments control the printing press. If they decide they need more money, they print it, which again leads to inflation. This, as we saw in 2008, can erode trust. And when there is no trust, markets tend to shatter. This was the problem Bitcoin aimed to fix. Decentralized ownership and a capped supply helped break away from the governmental dependency and lingering inflation. But it was not the only one. In TradFi, you have to share personal data to make transactions, which exposes your information to potential theft. In decentralized systems, on the contrary, your data is safe. You transact by simply connecting your digital wallet. With no sensitive information flying around, the risk of intercepting is little to none. Another problem of the TradFi is financial inclusion. A share of the world's population can't access financial services. In decentralized finance, users don't need a central authority to deposit, exchange, or withdraw money. People custody their own funds. With the degree of independence, there is no need to worry about losing funds. A bank can't freeze your assets as there is no bank as such, nor can it intercept your transaction. Blockchain protocols do what they say they will do. So once initiated, a transaction is irreversible. Now, you've probably sent money overseas and know the pain of waiting for days until it reaches the receiver. Add banking hours and public holidays, and you get 5 business days until the transfer arrives. Transactions on the blockchain, in contrast, usually settle in a matter of minutes. DeFi markets run around the clock too, so no need to wait for a bank to reopen in the morning. Then come fees. Traditional banking fees can eat significantly into profits, while transaction costs in DeFi rarely exceed few dollars. Handy if you are speaking millions. Cryptocurrencies like Bitcoin and Ether run on blockchains and let us all enjoy the benefits of TradFi. But as we said, blockchain is not only about money. Smart contracts are an interesting use case. Remember how we said Ethereum supports automatic agreements between people? That's what smart contracts are. Computer programs that execute on their own when predefined conditions are met. Contracts won't proceed until all parties fulfill their requirements. Pretty convenient, isn't it? Cross-border payments are also a popular use case. You remember that DeFi fees are way lower than traditional banking fees, right? Digital currencies are also available 24/7. That makes blockchain and crypto ideal for sending money internationally. But blockchain's potential extends far beyond finance. Its high data integrity ensures that the data stored on it is secure and tamper-proof. This makes it perfect for supply chain tracking. Healthcare also uses blockchain to securely store patient records. It is also finding uses in real estate, energy, voting system, and even charitable giving. That's it for today. Hope you've learned something new. Next, we will explore key concepts and types of blockchains. See you in the next lesson.